Hi everyone. Can you all see the whiteboard?
Yes.
Okay. What answers did you get for the first one? Okay, good. 45 is correct. Neil, can you explain?
So, uh, since it's a cube and the formula for volume is length, width, height, each side of the cube will be the same.
Mhm.
So for the cube having a side length 1, it would be 1 to the power of 3. And since there's 5 cubes with that, it would be 1 times 5. Uh, so and then uh and then the ones with the power of silent 2, it would be 2 to the power of wait 2 to the power of 3 times 5.
Good. Yeah, so
And I
the
just
good, yeah. So the key thing here is just that a cube its volume is the side times the side itself times the side itself, which is the side cubed. So once you have this, then we know side length 1 cube has volume 1. Side length 2 cube has volume 8. So if we want to find the total volume of the 5 cubes, it's 5 times 1 and then 5 times 8. Adding that up, you get 45. Any questions on this? Okay, let's move on to the second one. Okay, good. 55 is correct. Sharat, can you explain?
Yeah. The next largest palindrome after 15951 is 16061. So you just subtract you just do yeah, and then you get 110. But they're asking over the 2 hour period, so you just do 110 divided by 2. And then you get 55.
Good. Okay, so we know that 15951 is a palindrome. The next palindrome after that, so for that, we can just double check that there's no palindrome in between. So how do we be sure of that? So let's see, 15951. So palindrome we know has to have the same digits in reverse order. So in this case, the first and last are the same, the second and the fourth digits are the same, and the third digit can be anything. So by just changing the third digit, we'd only go lower, right? This is already a 9. So the next thing that has to change is the second digit. So it would be 16 something 61. Could be a palindrome. Now to make it as small as possible, this would be 16061. So that would be the next palindrome, and that's when Megan was 2 hours later. So 16061 minus 15951 gives us 110. And since that took 2 hours to go this distance, the average speed is 110 divided by 2 is 55. Any questions on this? Okay, let's move on to the last one. Okay, I see one answer. Are there any other answers? Okay, so I don't think it's 1 over 15, but Ishan, can you explain how you got 1 over 15? We can then see.
Yeah. So if we start off with a red and a blue ball,
Okay.
the probability of, okay, let's just assume we're going with red first. So we have 1/2 chance of picking that.
Okay.
And then we have 3 balls, right? So then it's 2 red and then 1 blue. So then we have a 2 over 3 chance of picking a red. And then, okay, and then if we do 1 more, we get 4 balls and then 3 of them are red. But now we have to switch to blue since we already have 3 red. So then we have a 1 over 4 chance of picking a blue. And then after that, we have a since we have 5 and 2 blues, we have a 2 over 5 chance of picking a blue. So if you just multiply, you get I think it was 4 over 120, and then that's 1 over 30. But since we have 2 different color balls, we have to do 2 times 1 over 30, and then I got 1 over 15.
Okay, so why did you multiply by 2 at the end? You said there's 2 color balls.
Yeah.
Okay, so is that because you are considering the opposite order of like picking a blue first?
Yeah, that's what I was considering.
Okay. Yeah, so I think you're on the right track, but let's think about this a little bit more. So we're initially starting with a red and a blue ball in the urn, right? Now, we know at the end, after 4 iterations, the urn will contain 6 balls. And we want to know the probability that it contains 3 of each color. Now, so if for 3 of each color, we know at the end, we want to have 3 red and 3 blue, and we want the probability of that. So now kind of the case you're computing the probability of here is, okay, you have a red and a blue. The next time you add a red, you add a red, you add a blue, you add a blue. So when you get all of these together, you do end up with 3 reds and 3 blues. Now, that's not the only possibility, right? So what is another possibility that could happen here?
Would it be red? Blue, red. Could it be blue again? Or
Sure. Okay, so red, blue, then blue again. Okay, then what else?
and then could you have a red
Okay.
and then red blue red.
Okay. Yeah, so this is also one possibility, right? So you start with a red, blue. The first time I pick a blue, then I get a red, then I get a blue, then I get a red. And what do I still end up with? I still end up with 3 reds and 3 blues, right?
Yeah.
So I think in your solution, you covered the first one, and you might have covered one more, which might be the opposite case, but there's actually a few others here we can fill in, right? Let's see what else are possible ways of getting to 6 balls with 3 of each. What are some other? So the first red and blue are fixed.
Yeah.
Kind of put a dash here to mark that those we know are already there. What happens after that? So I could either pick red, red, blue, blue. I could pick blue, red, blue, red. What else could I pick here?
Blue, blue, red, red.
Good. What else?
Red, red. Oh, no, we already did that.
Red, blue, red, blue.
Can you repeat that?
Red, blue, red, blue.
Good. Yes. What else?
Blue, red, red, blue.
Good.
And then blue, and then red, blue, blue, red.
Good. Okay. So how many total ways are there?
6.
6. Good. Okay, can we be sure that there's no more than 6? So I know we haven't gotten to the final problem yet, but have we covered all the orderings here?
Yeah.
Good. Why?
Because there's like no more possible combinations.
Good. So can we it's kind of what is like in terms of combinations, is there a way to represent what we just did? basically there's 4 things we're trying to add here, right? Out of 4, we know 2 of them have to be red and 2 of them have to be blue. So basically we were saying in these 4 positions, we want to choose 2 of them to be red. And what are the possible ways for that? So this should actually just be 4, choose 2, which is 6. And this was the 6 that we've already listed here. So we can confirm that there's definitely no other ways because we've already covered all the ways to choose 2 from 4 here. Okay, so now that we've done this, let's start kind of using the same approach that Ishan showed for the first one, and let's try to repeat that for each of the other ones. So you start with red and blue. Now, if we're picking this first ordering here, we want to say, okay, the next one I pick needs to be a red. What's the chance of picking a red here? So the urn has 1 red ball and 1 blue ball. So what's the probability of picking a red
50%.
one? Good, 50% or a half. So actually, let's move this for right now. Okay, so you have a red and blue. You have a half chance of picking a red. So once you've gotten a red, now what does the urn have? It has 2 reds and a blue, right? Because when I pick a red ball, I'm going to return the same ball and 1 more of the same color. So now what's the probability of picking a second red one? This one here.
2/3.
Good, 2/3. Okay, now what is in the ball? What is in the urn now? What are the colors? After I've picked the second red one.
Red,
R.
red, blue, blue.
Good. Red, 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 blue. Okay, so now what is the next one I need to pick?
A blue.
Good. What's the probability of that?
1/4.
Good. What about the next one?
Red, 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 blue, blue.
Good. Now the last one, what is the probability of that?
2/5.
2/5. So okay, so now we can just multiply these together. 1/2 times 2/3 times 1/4 times 1/2 is equal to, what is this?
4/120.
Good, which is
1/30.
1/30. Okay, so this is correct, but this only covered the first case here, right? But we actually have 6 of these cases to cover. So let's try repeating this for the last one, RBBR. Can we do the same kind of logic there? So what's the probability of picking the first red one?
1/2.
Good. What's the probability of picking the first blue one? Or is the first B?
1/3.
Good. What about the second blue one?
1/4.
Close. By picking the first B, we've got an extra blue, right?
Is it 1/2?
Good. So we'll just write it as 2/4 to make it easier. Yes. And what about the last red?
2/5.
Good. What is this probability?
4/120 or 1/30.
So this is interesting. This 1/30, this is 1/30. This is also 1/30. Any guesses about all the other ones?
It's all 1/30.
Okay, that is correct. It might not be immediately clear why that's the case because we had different probabilities here, right? Because here we had a half, 2/3, a fourth, 2/5. Here we had a half, a third, 2/4, and 2/5, right? So it's not immediately clear that it will be the same, but let's just assume it is. So if it is the same, what should our answer be?
1/5.
Good. Why?
It's just basically 6 times 1/30.
Good. 6 times 1/30. So, okay, so one way of doing this now is you've seen how we did the first one, you saw how we did the last one, we can repeat it for all the other ones, and you will see they're all 1/30. Okay, can anyone give me an explanation of why they're all 1/30? Or can we prove that they will all be 1/30?
Because like the combination is like ultimately like 3 reds and 3 blues, so like it'll always become like 1/30.
That's the right like kind of intuition, but let's try that might not always kind of be the case in some setup. So let's try to think about it kind of a little more in terms of the probability and see how this would happen. So for this, let's actually separate the numerator from the denominator when we're thinking about these fractions. So let's think about the denominator here. So the first one, what is the denominator for the first probability here? Whenever I pick this one.
2.
2. Why 2?
Because there's 2 balls.
Correct. There's 2 balls. What about for this one?
3.
3. Because at this point, there's going to be 3 balls there, right? At this one?
4.
And this one?
5.
5. Good. Okay, so we know that whenever I take the probabilities, and we saw that here, right? 2, 3, 4, 5. We saw this as 2, 3, 4, 5. The denominator is always 2 times 3 times 4 times 5 when I multiply the fractions. So let's actually just write that here. So denominator always is going to be 2 times 3 times 4 times 5. It might simplify, but let's not worry about that right now. So denominator is going to be 120. Now let's think about the numerator. Now, when we think about that, what is the numerator of the first one here? What will it always be?
1.
1. Why?
Because there's only like one possible option. It's
Good,
either
yeah.
you pull or a blue.
Yeah, it's either a red or a blue here, right? So it could either be, I either have to pick the red one or I have to pick the blue one here. So that will always be 1. So the first numerator is going to be 1. Now, what about the second numerator?
Couldn't it be 1 or 2?
Good. So that could be a little confusing, right? Because here in the first one, we saw that it was 2. Here we saw it's 1. So now we're not sure whether it'll always be 1 or always be 2. Let's think about it a slightly different way. Let's say the first one is a red. What about the term of the numerator for the second red one? What should its numerator be?
2.
Why?
Because we already have a red. We only need 1 more. Wait.
Yes, you're right.
Okay.
So when we think about the second red here, right? So let's say the first one was a red. Wherever the second, there is going to be a second red somewhere here, right? It'll be in the second, third, or fourth position. If you think about that red and what its numerator should be, its numerator is basically how many reds are there already divided by how many total balls there are. So how many reds there are already can only be the one original one and the one before, because we know this one was another red, right? So we know that the second time a red appears, its numerator is going to be 2. The first time a red appears, it's going to have a numerator of 1. So we know that one of this numerator is going to be 2. That position might either be here, or in the second position. So that's why we don't know if the 2 is going to appear in the second position or the fourth position. So we do know that another one of the numerators has to be 2. Now let's do the same thing for the blues. What is going to be the numerator of the first blue that appears here?
1.
Why 1?
Because there's only one option. So
Good. So wherever the first blue appears, it could appear here, it could appear here, it could even appear at the third or fourth, as we see the third one here. When it appears, we know that there's only been one blue before that, right? So there's only one blue in the urn. So the numerator of the first blue has to be 1. And what about the numerator of the second blue?
2.
Good. So we know that the numerators are going to be 1, 2, 1, 2. But we don't actually know the ordering. The cool thing here is the ordering actually doesn't matter. In this case, we saw that it was 1, 1, 2, 2. In this case, we saw it was 1, 2, 1, 2. And you'll see other orderings when you do the other ones. But all the cases, all we really care about is the product here. So since we know that 2 of them are 1s and 2 of them are 2s, that product will always be what?
4.
So is this clear why the fraction is always going to be 4 over 120 or 1 over 30?
Yeah.
Yeah.
Okay, good. Yeah, so you can, if you want to try it out, you can actually go through all of these 6 cases and confirm that this is the case, but this is an explanation of why. If I think about what the numerator and denominator is for each of these, we'll always get 1, 2, 1, 2 in some ordering. So I'll always get 4 over 120 or 1 over 30 for each of these. And since there's 6 different orderings, I should have a total of 1 over 5. Any questions on this?
No.
Okay.
No.
Okay, that's it for today's class then. We'll see you all next time.
Thank you.
Bye. Thank you.
Yeah, bye.
Have a good day.
Thank you.